Hey everybody, this is Larry, this is me going with Q2, I had the wrong number of fingers, I'm having a weird day, of the bi-weekly contest 171, minimum operations to make binary palindrome. Hit the like button and subscribe and join me on Discord, let me know what you think about this one. I think the hard part about this one is recognizing what is the worst case scenario. I also misread this a little bit. If you watch the live portion, you'll see how you'll see how I misread it. I just kind of, misread it. But the key thing is that, well, by definition, the number one is a binary palindrome. And that means that, and then look at the constraints, it only goes up to 5,000, meaning that at the worst case, 5,000 is going to be, like even without any context, if you go from if you do all the checks from 5,000 to 1, going down, that will give you an answer, right? Because pigeonhole, whatever. You could also probably say that if you multiply by 2, that would also give you the answer, though that's a slightly trickier proof to do. And you can also do it by just pigeonhole, right? Because it's a slightly harder proof, but it's not a difficult proof. It's just that if you multiply by 2, what does that mean? You could think of that as shifting, right? Or multiply by 10 in binary, right? And because of that, you know that you passed the number with all ones in it, right? And that's basically it. Like, for example, if you have like number 9, right? 9 times 2 is going to be 18. And within that, there's a power of 2 that's inside between 9 and 18, which is 16 and then you minus 1 to get the all ones. That's a palindrome. So there are a couple of ways you can kind of show to yourself that at worst for number x, it's going to be 2 times x will give you the answer for any result. And of course, realistically, the answer is going to be much closer, just, and I'm curious, so we'll do some testing soon. But that's basically, based on that idea, I just brute force going up and down, right? So for each number x, I try going up and down, and I don't know, I just add 2 just in case, I don't know, right? But basically I do plus I, minus I, and that just counts all of them. And this is how I, do the binary palindrome thing, meaning that I just get a binary number, or the binary string, and then reverse it. If it's the same, then we're done, right? So that's basically the idea. And yeah, like I said, you have 5,000 numbers. Each of them goes as a high upper bound, does 5,000 of these loops, and each loop, each loop does say O of, 5,000 is what, like 14 or something, 13 binary digits. So yeah, so 5,000 times 13 is the worst case-ish, right? But you could probably figure out that the actual bounds is much smaller. So I'm going to just actually do a quick thing. Maybe this works, maybe it doesn't, right? Let's see if this times out anyway. No, it actually see, it runs pretty fast for all 5,000 numbers. Actually, I'm surprised at how fast it runs it. Actually, because you, and you could see that, I don't know, just eyeballing, the biggest number is like 40 or something, right? And that's it. Mine took 1.4 seconds. Honestly, what I probably should have done, but I didn't, is a very simple, well, put this, is that we could have probably just, well, one, we can cache all the answers, right? So there are things you can do. So let's actually upsolve this a little bit. We saw that this one took 1.4 seconds. The first thing that we can do is just that, we can cache this check, right? So maybe here we have def good of x, right? And then it is just this part. Right, so then now if good of x plus I or good of x minus I will return I, right? And the reason why I don't have an else is because it's guaranteed to be true, right? Because you can go to 1, like I said. Oops, and now we don't need this anymore, say. Right? Let's give it a quick submit, if I could find a submit button, and see. So that the other one was 1.4 seconds, and now you can see that this array dramatically improves this in. And then now you can actually even just cache this, right? So yeah, so maybe we could put this here. And then now each number should have only done it once. And ooh. Oh, what? How did that happen? Yeah, and now you have fractions of a second in just 2 optimization. Noticing that, well, for this one, the numbers don't change depending on the input, and this neither. So that's it. That's kind of funny because I probably should have thought about this during the contest because I was a little bit worried that it would time out. And this was a very trivial changes. You just saw like 2 trivial changes. But of course, if I had timeout, I would have been able to find these optimizations. It's just that it didn't really occur to me to do them before I got a timeout. But it didn't time out anyway. But yeah, that's it. That's what I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live in the contest now. Specific with like it has 2 devices or something, which, you know, but I guess they just, I don't know what happened to this UI. Okay, but it's worth spending an extra second sometimes because otherwise you get a 5-minute penalty and it's just dumb. Okay, increase numbers by 1, decrease by behind everyone. Okay. Num sub I, okay. So, okay. That seems pretty straightforward. It's just the number of deltas, right? Divided by 2 or something, right? Something like that, right? Nope. Something like that. Right. 0, 1, 1, 1. Ooh, I almost messed up. That, oh, huh. I messed up. I thought you could choose which digit to do it. So okay, so this is not right. And I have to think about it a little bit more. Okay. Well, they only go up to 5,000, which is interesting, maybe. Well, that means that at most each one of these does 5,000 operations, so you can increment, and that go. I guess you just kind of yeah, do it. You have to try to do it fast, I suppose, and not one time. But I think there's like a pigeonhole thing. You just 5,000 operations. Well, if anything, you could go to 1, right? So, yeah, okay, fine. Is it 2 times X? Probably. I don't know. I don't know if this is like the best way though. This may be a little bit slow, but go to it this way. This isn't even right, but what? I know that maybe I have to convert this to a string, but I was hoping that it just does like a you know, like a pairwise comparison, which apparently not. Okay. Is it fast? I don't know. Or is it fast enough? I don't know. Because it's going to be 1, 3. There are a lot of numbers that should be good though. So maybe it just should be just fast enough. We YOLO submit, and hopefully we don't time out. Okay. Was a little bit worried about the timeout, but thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these forums, everything in between. Stay good, stay healthy to mental health. I'll see y'all later and take care. Bye bye.